Assalamu alaikum. Good evening.
Waalaikumsalam, sir.
Oh, apa kabar?
Good, sir. How are you?
Alhamdulillah.
Baik, sir. Alhamdulillah.
Nice to meet you this evening. So, inshallah, today we are going to continue our lab exercise on the classification and then a little bit about evaluation. How do we do the classification, and then how can we understand how this framework, a particular model is evaluated, maybe to give us the accuracy and then some certain aspect of true positive, true negative, false positive, and false negative. And I hope you have gotten all these documents in your group. The lab exercise is here. Can you see the screen?
Yes, sir.
Okay. So the file is there. And so maybe without much waste of time, we can go ahead and load your Weka and then start the classification. So today, actually, you could remember the previous weeks we are discussing the data understanding and then pre-processing. So today we are going directly into the classification using the classification tab in the Weka and see how we can develop a classification model, a model that can classify values according to the classes of that data set. So for this exercise, we are going to load the iris data and then use J48 as an algorithm for our classification this evening. So make sure your Weka is ready. Is your Weka ready? Is your Weka ready to go?
Yes, sir.
Okay. So load the iris data. Load your iris data set from your data folder. Here is my iris data set. Are you there?
Yes, sir. Yes.
Okay. So how many instances? How many attributes?
150 instances, 5 attributes.
Good. So is there any missing value? Can you check? Do you have any missing value? Missing data?
No missing, sir.
No missing data. Okay. So let's go ahead to the task. So the first instruction is to leave the test option as template. So you look at this here, down here, under the classify, because we are moving to the classification. What do we see? What do we see in the instruction? We are going to use J48. How do we get to the J48? Under the classifier, it is under the tree algorithms because J48 is a tree algorithm, and then you select the J48. Can you go ahead to do that? Classify. This is where we have the classifiers, which I have explained it in the class. Then trees are down there, the last algorithms, group of algorithms that call trees. You can see decision stem algorithm, helping tree, 48, LMT, random forest, random tree, rep tree. All these are the tree supported algorithms. So for our exercise, we are going to use the J48. Okay. So now the next instruction is saying we should what? Leave the test option as cross validation. That is, so when you come here, you will have the test options down here. We have different test options. One is the user training set, which is a full training set. Here we supply the test set in which that we save our model. We want to test the model with the unknown data, unknown class, without the class level. Then we can test the model, which we are going to do later. And then the cross validation, which will allow the data to be divided into the number of faults. So in this case, we say tenfold. That is, the data is going to be divided into 10. Then the fraction of data will be taken. Let's say for each of the data, one will be taken as a test data, one as a the second portion, the remaining portions or 9 portions for training the model. So this is how it will be combining the different sets. And then also there is a percentage split where you can divide the data into some certain percent. Let's say by default we have 66 here. So if you select 66, that means the remaining 34 are going to be used to evaluate the model. If you take 70, that means the model is going to be trained with the 70% of the data. And then at the testing level, it will be tested with the 30%. If you choose 80 here, then 80 will be for training the data. And then the remaining 20% of the data set is going to be used to evaluate the data. So this is how we can select the test options. So for this one, we say we leave the cross-validation as 10 as it is. Okay, let's see, is there any other instruction? No, it's just now to click start. No need to change anything so that we see the output. So can we click start now? Are you there?
Yes. Yes, sir. Yes,
Okay,
sir.
so now here you can see the running information which we have been discussing in the class previously, where you see the name of the classifier here, which is a J48 tree algorithm, the relationship of the data set, which is iris data, iris flower, and then number of instances is there, number of attributes are there, the list of attributes are there also, and test model, the option we have chosen, which is tenfold cross-validation from here. And then this is where we have the training, which is J48 training tree. So now this is where you have your model here. You see the model? The model is simply the if-then rules, as we have discussed in the class. So when you have the if-then rules, if this happens, then this will happen. So based on the information in the data, this data set actually contains some values. These values are indicating because of maybe the length or the width of the petal or the width of the sepal will determine which what class of the data is going to be. So you can see, for example, here the first one, if the petal width is less than or equals to 0.6, so the flower is going to be iris setosa. So the second rule is saying if the petal width is greater than 0.6, sorry, excuse me. So this one, since it is greater than, so definitely we will have another set of rule because greater than is greater than. So at which boundary are we going to have different classes? So if it is greater than 0.6, 0.6 can be up to what? A limited value, which is greater than 0.6. But here, because we have limited values, say, okay, now it is greater than 0.6, but this petal width is less than or equals to 1.7. That means it is between 0.6 to 1.7, another condition. And then also another condition, if the petal length is less than or equals to 4.9, then the flower is going to be iris versicolor. So initially, and then continuously, this is how you will see the if-then statement. At maybe in the class, we are in the class, maybe I can show you how the rules are being established there. So these rules are what actually tell us how the model can work and then classify all these classes. So you go back to the data here, you can see initially the classes are 3, and then they are divided accordingly, actually evenly. Each of the class is assigned 50 instances out of 150 instances that we have. But now what the model is trying to do to understand this information from the this particular data variables, and then to confirm whether this particular classification is okay, and then if it is okay, then you can save it for future predictions. So now you can see that if you go down here, you can see the number of leaves. Here you can see 1, 2, 3, 4, and 5. Wherever you have the termination of the of the value of the class. And then generally here you can see that you can have the size of the class as 9. So continuously you count this, you can have 9. 1, 2, 3. So you have 4 branches plus the 5, then you have 9. So now let's go back to the question so that you can understand it step by step. The first question we want to answer here is how many levels, how many leaves in the decision tree, and what is the size of the tree. So if you go back to the model, you can tell us the number of leaves, and then what is the size of. So now going back to our model, how many leaves do we have?
5.
5, good. So you solve, write down in your solution. How many, what is the size?
9.
9. So this is the first question. You can screenshot this portion where you have 5 leaves and then what? The size of the tree as 9. So I will show you this one in the tree. And then the next question is describe the rules generated from the decision tree. So these are the rules that I was trying to explain to you here. For example, in this particular, this is the rule. But always, as we say, the machine learning, trying to understand the rule. So it is trying to say that if the petal width is less than or equals to 0.6, then what is going to be the class of our flower here? Okay? So now the rule is trying to say, okay, now, let's say now I want to answer this question. Okay, now if, because we are always working on the if statement, if petal width left them, and we see what is there, is less than or equals to, okay, so if it's less than or equals to, let's say less than or equals to 0.6, then, because this is the rule, then look at the flower. Which flower is this? Then this is a flower we are going to have, Aries setosa. So the rule is telling you that if this rule satisfied, then the flower you are going to see is going to be what? Aries setosa. This is why it's asked you to describe the rule. The rule is already there. Because all you want to do is to understand how this rule is what. Saying machine learning is always working with the if then statement. So the rule is going to be what? The knowledge that the algorithm has. Now algorithm is pre-trained with this particular data set. So okay, now whenever we have something like this, then the flower is going to be this. So if it comes to the time where you are feeding the model with the information without this particular class level, then it will give you the rule. So another rule we can derive from here is that if you look at this one, another rule is here. If petal width is greater than 0.6, now since this 0.6 has a limited value, anything greater than 0.6, so they have limited it here. And petal width less than or equals to 1.7. So maybe when you go, let's all go to the tree. So you can right click here and visualize the tree so that you can see the rule clearly written in the tree. Can you do that? Right click on the model here, then visualize tree. Can you see it?
Yes, sir.
Okay, visualize tree. So can you see the tree now? So that means this one is saying that if the petal width is less than or equals to 0.6, then this is the termination of the condition. Now the flower is Aries setosa based on the class. Then the next rule here is because 0.6 can be unlimited. So now this is why you have another condition. If the petal width is greater than 0.6, now you have a condition here because petal width is another half divided because greater than 0.6 is unlimited number. but we want to see whether it is terminated at a particular point. And this petal width is less than or equals to 1.7, and petal width greater than 1.7. Now, this 0.6 greater than 0.6 is divided into 2. If the condition is saying that the petal width is greater than 0.7, and at the same time it is greater than 1.6, so the flower is going to be Aries virginica. So this is another rule. So for this one, we say petal width greater than 0.6, and that petal width is also greater than 1.7, because greater than 1.7 is also greater than 1.6. Then the flower is Aries virginica. Then you can put down to a template and say, okay, now another rule is if petal width are greater than, let's say greater than 0.6, now we are going to have the connection, and because 0.6 is what? It's a big number. So we want to terminate it at a particular point so that we have the rule completed. And the petal width, sorry. Now look at the condition. What is this saying here? Greater than 1.7. Then Aries virginica. So now it is still greater than 1.7. So now we say then Aries virginica. This is a flower. So now this is how the rule is. Now it's telling us this is a class. So continuously you can have as many rules as possible. So here is also another rule coming down here. The petal width less than or equals to 1.7, and the petal length less than or equals to 4.9, then the flower is Aries versicolor. But petal width less than or equals to 1.7, and petal length greater than 4.9, and petal width greater than 1.5, then this is Aries versicolor. So you remember, we say what is the leaf? What are the leaves? How many number of the leaves? What are the number of leaves? So these are the leaves: 1, 2, 3, 4, 5. The rectangular shape. Size of the tree, you count all the nodes here. 5 plus 6, 7, 8, 9. So all nodes that we have here, whether rectangular or oval shape, collectively is what we have as the size of the tree. That is why we have 9. But the leaves here, where the rule terminates, this is where we have what is called a leaf, because the algorithm, we call it a tree-based algorithm, because we selected the algorithm under the trees. So this is why it's giving you this. A particular tree must have a leaf. But this kind of leaf actually is the root is on top, unlike the normal natural trees that we have, where we have the roots on the ground. So this one, the root of the tree is on top, where we started started training the model. So now let's go back to the template. I have given you some, then you can finish the rules later. And what is the percentage of correctly classified instances? We're now going down to the evaluation section. Okay. So even the time taken to build the model is here, because the data is small. You can see even the time is not recorded, because just significant number, maybe 0.000001. So it just says 0. So now, since it uses stratified cross-validation, I think we will discuss this when we come to discuss evaluation during the lecture. So now, correctly classified instances out of 150 instances that we have in the data set here. So you can see that 144 are correctly classified. Why? Because there are 6 instances that are saying that they are not supposed to be in their designated classes. So we have the actual what do we have in the actual data? All of them have 50-50 instances. But now, some of the classes are saying, no, based on this model, these particular data as instances are not supposed to be in that class. But now, if we are talking about the accuracy of this model, we are talking of the correctly classified instances. How many percent do we have?
96.
That means that 96% accuracy of this model. So the accuracy of this model is 96% over 100. So that means it performed well actually on the data because it was able to classify correctly instances about 144 instances. So what of the incorrectly classified instances?
4%.
How many percent?
4%.
So that means there is 4% error in this model. So this is where the basis of this error is coming up. The total number of instances is this, but there are some errors like the mean absolute error, root mean square error, relative absolute errors. This indicates that this 4% is an error in the classification of this model because it has not classified it to be in its own class. Because initially each of the class has 50 instances, but now some maybe has reduced with 1, some with 2 instances. So we will see when we come to discuss the confusion matrix now. Okay, so now what will be your answer here?
96%.
96%. Good. So you can screenshot that portion and put it in your file. So now, next is to look at the confusion matrix. Confusion matrix is the basis of the evaluation of the model. This is why the model is being evaluated by considering the true positives, true negatives, false positives, and false negatives. So from there, then we can derive even the accuracy of the model can be calculated, can be derived from this value. So when we come to do the evaluation, we'll see the formulas and then how we can calculate the accuracy, precision, recall, and then even the F measure of the model. So now, let's go back to the model and look at the confusion matrix. Let's forget about this detail of the evaluation because all this detail is derived from this confusion matrix, the calculation from these values. So now, here you have classified, that is the prediction from the model. And then what do we have down here? This is why we have the actual instances that are in the data set. So vertically here, we have the actual 49000. But this horizontally, this ABC is indicating the classified one. That was based on the classification by this model. So this A is indicating what? Aries setosa. B is representing Aries versicolor. C is representing Aries virginica. That is based on what? to the template and see what we are going to do next. Okay, so now using different test option, look over the different test option by selecting the percentage split. So now we are going to change only option. By default, the percentage split is 66%. That is in the tax 2. Or should I give you some time to finish the tax 1? I'll give you like 10 minutes.
10, sir.
Okay,
Yes,
so
sir.
maybe you can repeat the process and then look over these rules and then write down maybe about 3 or 4 or 2 additional rules so that we have 4 rules here. Okay, I already did for you. Then use the concept and drive another rules. Let me give you 10 minutes to finish the tax 1, and we move to the tax 2.
Sir,
Yes.
may I ask for true negative is the total of the true positive for B and C, is it? For
Yes, yeah, right, you are right. For
Alright,
A, if you are referring to class A, the same, because the name of the attributes must be the same as they are here. They are case sensitive. So make sure the spellings are the same. No use of capital and small letters. Make sure you write them as they are here, because there will be an agreement between the attributes. Okay, is your file ready?
Yes.
Okay, so let's go back to our model here, to our Weka. So now, assuming you have already saved your model, maybe you have closed your Weka, and then you can come back and say, okay, let me load the model. Let me assume I don't have anything in the Weka. I just close my Weka and then open it again. Close everything. Maybe after some days, you may decide to say, okay, now I want to test this model with a particular data set. So you need to load the Weka again, open the Weka so that you don't have anything. So remember, whenever you want to use Weka, definitely you must load the data set, because you cannot have access to the remaining tabs. This time around, we are just loading the data set because we want to load our model. So we just load the data set so that we can have active tabs here, not because we want to use it for our analysis, because we already have the model. So now let's open. So in this case, we can load any data set of your choice, just for you to have access to the classify option or classify tab. So let's at the same time load the arrays, as since we are using arrays, but actually you can load any of the data. So now our concern is this one, because now this one is active when we load the data set. So now we already saved our model as arrays model. So just come here to the result list panel, right click anywhere. Can you see everything inactive but what? Load model. Can you see it?
Yes, sir.
Load model is active. Now you are loading the model. Where do you save your model? I save it in my file, in my folder. Can you see it? Aris model new, the one I saved this morning, this evening. Aris model, then you know how where you save your own model. Just load the model. Do you see the model now already here? This is what I was telling you.
Yes, sir.
So in the model, you can only see the roots, no any evaluation, because this is the rule. This is where we have the model, where we have the rules that can help us to do the prediction. So this is why you didn't see any evaluation here. So now we are going to change another test option now. Which one are you going to use? Supplied test set, because we already prepare our what? Test set. You get the point?
Yes, sir.
Okay, so now we say supplied test set. We can see this one set active. Click on set. It will give you this box, this dialog box. Now we have options. If we are bringing data from the URL, then you can bring your data. But in our own case, we are going to open our file, the file that we save in our computer. So open file. Good. Where is my data? Let me go back to the here. All files. Can you see my ARIS data? Can you see it? ARIS tests. Do you see it?
Yes, sir.
Yes, sir. Yes,
Okay, so now here you select the option CSV. It is a CSV file. Do you see it here? ARIS test. It is a CSV. Then open.
Yes, sir.
When you open, can you see the instance? It's telling you that the class is a question mark because we put question mark in our classes. You can see all the attributes are here. Can you see them here? Okay. So now we have already supplied a test set. You can close this one. Do you see it?
Yes, sir.
Just close. Now go back to your model. Before then, we need to see the evaluation, or we need to see the prediction. So now, test option here, you choose plain text. Can you see plain text? Instead of null, before it was null, now we use plain text because we want to see the prediction classes. Okay? That is the output of our prediction. We want to see it in a plain text. You get the point?
Yes, sir.
Okay, so now we close this one. Now, next, we are going back to our model here. Right click on the model. Are you there?
Yes.
So now we are going to reevaluate the model because before the model was reevaluated automatically by selecting the cross-validation or split, for example. In this model is a cross-validation. But now we are evaluating it with what? With the data set with no class value to see whether the model can do the prediction, right? So now we say reevaluate on what? Current test set, the one you have already supplied. Reevaluate on what? Current test set. Are you there?
Yes, sir.
Okay, you just select. Can you see the reevaluation? Are you there? What
Yes.
we have here is the same, but now this is a reevaluation. Users applied tests. What tests you applied? I applied the ARIS tests, which is my data set, instances or none. Because when you supply the test set, it does a question mark. So they didn't know the instances. Now the model is predicting. Okay, we supplied 6 instances in our data set. Can you see the actual? The actual is what? The actual class is what in the data set? It's question mark. What is our actual class here? Question mark. No value. So now the model is telling us that actually it is a question mark. But now, what is the predicted value? Instance number 1 is ARIS Setosa. So the model prediction is telling you what you have here is ARIS Setosa. Right? Then instance number 2, what is there? ARIS Versicolor. So now the prediction is telling you what you have here is supposed to be ARIS Versicolor. Now the model understands that they have the knowledge now from these rules. Then it uses the rules and then predicts where you can assign these values. This is the essence of doing the classification. You train the model with the classifier, then finally you can use that model in your subsequent work to say, okay, now let's use the model to do the prediction. You get the point? So at each point, you can see that there is a prediction error. If there is an error, then it will indicate. If there is no error, it will give you the result. Like this one, you see 100% accuracy in this prediction, 97% or 98% accuracy. This one also. So that means the model do a very well prediction in this case. Okay, total number of instances, and then on non-instances 6 that we have supplied to the model. Any question on this?
No question, sir.
So do you see now how we can use the model to do the prediction?
Yes, sir.
Good. So what is the next question in our template here? Okay. Okay, this is the information I am giving you. The class attribute is unknown, which is a question mark, or you do not know the classification. Yes. So it's just to show the process, which we have already done. Now you can show the process by screenshot, or maybe you say you can briefly explain how you follow it and then how you do it. Maybe by loading the model, then supplying the test set, and then you see the prediction in the model. So now for tax 3, it's all the same. I want you just to repeat the tax. Okay. Is the tax using just the tax that you are going to repeat is what we have in tax 1. That is, you develop the model using J48, and then you just use the test option of k equals to 10, all true. But now we are going to apply 3 different algorithms. So find out where you can get these algorithms is classification models, classification algorithms. Then even though the time sometimes is going to be 0, so this is what I am asking. If you refer back to the model, you see that it's a time taken for the model to build. So if it is 0, you just write 0, no problem. I'm just giving you this table to guide you on how to record or how to report your findings. For example, here you already have the data set. Let's classify it using J48, for example. This is null, I think. So now let's say we classify this one using cross validation 10 start. So this is the information about the model. And then the time taken to develop the model is here. Can you see the time? It says 0. So now you can write this 0 in your, because it's a fraction. Maybe if you use different data sets, which is big, then you can see it taking a lot of time. So what is the accuracy? Correctly classified instances. Class A, what is the precision of class A? If you refer back here, what is the precision of class A? This is the class A. What is the precision? What is the precision of class A?
1.0001.
1.00. Oh, we see 100%. What is the recall of class A?
0.98.
Okay, what is F measure? F measure is the harmonic mean of precision and recall. What is F measure?
0.99.
Good. So this is what we are going to report. What to for class B? The precision is
0.94.
good. Recall is 0.94 again. And F measure, because it's a harmonic mean, it is also the same 0.94. So this is what you are going to do. Just use different algorithms. When you get the results, then report the result here. And that is all for, because we are trying to compare the accuracy of the model from the tax 1, tax 2, and tax 3. So now we already have the result of tax 1. Now repeat this with these ones and then see where we have the best. From this comparison that we can get the best model for you to save for further prediction. Okay, in this case, we are just going to do the classification and then write down the solution. Do you have any question on this tax 3?
No, sir.
Okay, I think you can finish it. So I will give you time. Maybe I will end the meeting and then I will give you time to finish, then you can submit later in the day.
Sir.
Yes.
So for the detailed accuracy by class,
Okay.
The column is for the different method, is it?
Yeah. If you
Oh, okay.
apply naive Bayes, so what do you get? Like here, I apply J48. So this is the information about J48. Okay. So if you apply another algorithm, naive Bayes, this is the information about the naive Bayes. Biking, this is the information about biking in the column against their columns. You get the point? Do you get it?
Yes, sir.
Okay. So I think before we end the meeting, then we need to discuss about the project. So let's have some time to discuss the project. Then I will allow you to finish the task, right? So do you get this template in your group?
Yes, sir.
Okay, so this is your group project, which we supposed to discuss according to the lesson plan. I think we're supposed to have a briefing about this. Okay, this is week 5. Can you see? We're supposed to have a briefing about the project because next week, during the tutorial time, we are going to have a test. So it's good that we should discuss this. So these are the table of content about the project, and the descriptions are there. So the project is divided into 5 parts, ranging from A1, A2, A3, A4, and then the B part where you are going to develop the model. The A1 is about acquiring your data, getting understanding your data. And then A2 is how to start preparing the data by selection and then the cleaning the data. And then also A3 is also about the preparation, where you do the transformation, if any. I think we have done all this in the class. And then A4, we do the data reduction using the select attribute method. And then finally, we develop the model and we evaluate the model, which we have just did this week. So now let's go to the main points, right? So here is a description about the project. As I have been telling you in the class, we give you the project, we will tell you the kind of data set or the attributes or the properties that we need that data set to have. So we want you to find your own data set depending on your interests. If you are interested in health, go to the health. If you are interested in agri, you can go to the agri, but you are going to do a classification. So whatever is your interest, you just go and do that. Check to find out the data set on that. So the data set should contain enough instances, which is what? At least 3,000. When we say at least, we mean what? Not less than 3,000. So any data set that you are going to use, you must start from the 3,000 instances and above. Okay? And the attributes of this data set must be at least 20 attributes, up to 30 attributes. That means the attributes your data is going to have must be between 20 and 30, not less than 20 and not more than 30 attributes. So you can have 21, you can have 22, you can have 29, you can have 30. But more than 30 attributes, maybe you cannot accept unless on a special circumstance. So that is it. Take note of that. And that's the attributes including the 30 we are talking about, including the class level. Because sometimes, as we said, if we have 6 attributes, maybe 1 is a class. So we may have 29, 1 in the class. That is number 30. And then it should contain mix of numeric and nominal attribute values. So the data set you are going to use, don't go and download all numeric data attributes or all nominal data attributes. We need to see the mix. Because from there, then we want to know whether you understand the concept of doing the data mining well. Okay? And then, if possible, your data set should contain some missing values because we want you to do some data cleaning. So if there is no missing value, no problem, you can go ahead, but you have to think of which other filters can we apply in doing your pre-processing. Okay? And then second, you need to describe the data sets, the problem. When you get the data set, maybe you get it in Kaggle, UCI, or wherever, you may find out that maybe there is explanation or there is a paper that uses that data set. Then from there, you can see which kind of problem do they solve, and then which one are you going to solve in your own project, which is related to that data. So now you have to say also, okay, this is the kind of classification you want to do to classify maybe the diabetes patient based on the data set, or the cancer patients. So all these are the problems you want to define. So, and then also the data source. Where did you get the data, and then how did you get it? You have to explain it briefly as a background. And then each group is required to develop one method only, that is a classification, one task. We are not expecting you to do the classification and at the same time do the clustering or do the association reminding. No, we are expecting you to do the classification because the project is starting this week and we are yet to start the clustering part. So if in case any group is interested in doing the clustering, okay, now you can go ahead and start doing your own research. And then before we discuss clustering, maybe of a week, then maybe you can decide to discuss with me to tell me that, okay, now you want to do clustering tasks if you are interested. But specifically, we want you to do the classification. So these are the tags. These are the basic description. And then the tags in A2, A3, A4 is for data understanding, as I said earlier, preparation and reduction. And then while tax B is for model development and the evaluation. So strictly, we are going to use Weka. Don't tell me that you use RapidMiner to do the classification, to do the project. No, we want you to do the tax using the Weka because it's a Weka that we use in the class. And then you might need other tools such as Excel, as we did now. We use Excel to prepare our data. Then you can use Excel also to do some certain things or any other relevant thing like the PowerPoint or your presentation and the rest. So all these are the tools that you may need. And then the relevant attributes will be within 10 to 15 attributes. So sometimes students make mistake here because they misunderstand this point. So take note of this. We say relevant attributes will be, when we say relevant, we are talking about when you do the reduction. This is when we usually select the relevant attributes. So here we say you are going to use between 20 and 30 attributes initially in the original data. So after the data reduction, then the minimum we need to see is 10 attributes. So don't tell us that after data reduction, you are going to use only 5 attributes. No, this is what we mean by relevant. When we say relevant, we mean what? When you do the selection, so any of the methods you use, it gives you the relevant one for your processing. That means you are going to use 10 to 15. While the initially processed data, you are going to have complete your attributes and then develop the model with that one. And then after reduction, you use 10 to 15 to develop another model. You will see the flow in the end of the file. So for A2 is the data preparation. When we finish A1 here, A1 is a data acquisition and data understanding. I want you to understand how to do the. For A2 is a preparation. First part of the preparation is selection and cleaning. So what do you want to do? We want to do the selection so that we clean all the relevant attributes or samples. Meanwhile, data cleaning can be accomplished by applying filters. Yeah, this is what we apply in the class to the data and pre-process stuff. So no need to waste time on that. You know how to select the filter. So the first thing to do is start with the process stuff. Study all the numeric attributes because we say the data set should be a mix of numeric and nominal. So study the numeric, give the information about the data. Maybe you can create a simple table. All the numeric attributes that maybe you have 10 numeric attributes, you can create a table with a heading, mean, minimum, maximum, and then standard deviation. So just look at the data set. Like here, you have numeric attribute, for example, you just select it. Okay, if this is numeric, then okay, now what is a minimum, what is a maximum, what is a mean, what is a standard deviation. Just report in your table. That is all. Or sometimes you can just do a simple screenshot and put in your file. So that to show us that this is what you have. But summarizing them in the table is better and most easier for you so that you cannot have too much slides. with unnecessary screenshots. And then also do the same for the nominal attributes and report in your presentation slide. And then the third part of the preparation is to do what? To identify the attribute with missing values, or then you want to remove them from the data. You know how to remove the missing values. I don't need to explain this detail. Then next is identify the attributes with outliers. You know also how to identify outliers, and make sure you write the filters you use and then how you get to the filter from pre-program Explorer, and then maybe you choose filters, all these steps. You need to tell us how you get into that. Then identify the outliers and remove them. And then after this is where you are going to have your second file, which we call clean file, because you are what? Cleaning. So after A2, you have the new file, which is called clean file. Now you have the file number 2. Initially, you have your original file when you downloaded the data and you selected your relevant attribute, for example. When you download the data, now you have the original data. After cleaning, you have the file clean. Then you save it as you are, because you are in Weka. So it is that file that we are going to use as a file for transformation for the A3. So use that same process, clean file, and do the following activities in transforming your data. You can explore more available in the Weka. There are a lot of filters that can do the transformation. You can explore more. So, and then you can use also the ones that we use in the class. One is to perform normalization if possible. Normalize some of the attributes and then tell us which kind of normalization do you do. Either it is minimum maximum normalization, min max, z-score, and then or decimal normalization. When you need to provide detail on which kind of normalization you do, and then why do you normalize that particular attribute, and then state which one you choose and why. You may need to require normalizing all attributes. You may not require normalizing. This is what I'm trying to remind you. No need to say that you have to normalize all the attributes. No. Maybe you have 10 numeric attributes on your data set. No need to say you have to normalize, depending on your interest. Maybe some of the attributes are already normalized. Maybe they are in the maximum of 0 to 1. So maybe some are in the values, maybe 20, 40, 50. So you need to normalize them to go in line. That is the essence. So, and then explain, as we said, explain why do you do the normalization of the attribute, which is very important in project. You need to justify whatever you do. And then next is to do the securitization when necessary also. We're always saying when necessary because this is pre-processing of the data. When it is needed in your project, then you do it. Or if another one is needed, then you can apply it. And there are many filters there, then you can think of which filter is necessary for your project. And then you need to justify which attribute do you discretize, and then why do you discretize them. Yes, you need to explain all this. And then you need to perform the attribute construction when necessary. Maybe I don't need to tell you the filter for construction. Maybe you can search and you can find out it's an addition to your project. So if you need to construct attributes, maybe you need a particular attribute and you don't have it in your data set, you can construct. There is a way in Weka that you can construct attributes. Then you can do that. And then also you are free to perform any other pre-processing that can give you more marks, and then that can help you to have the better model and then the good model for in your analysis. Take note, we want you to do only the classification and then tell us the accuracy of the model. No need to do any prediction unless maybe when the need arises. So now we are going to save your prepared data set as well. File process. Now you have the file number 3. Okay, so you need to screenshot some part of the file as before also. In the previous one, file clean, screenshot like maybe 20 records and then put in your slides, show us that this is a file that you already claimed. And then for this one also, after pre-processing, then you also need to tell us or give us some part of the portion of the data. So now finish with the preparation, then you can use that data file, process file to what? To do what is called the selection, attribute selection. But before you do the attribute selection, you have to use this process file and develop your model. Take note of this. You have to use this process file. You will see the flow, then develop the model. If you want to use one algorithm, two algorithms, develop the model, record everything. Maybe you use the Excel sheet, record your result there, then jot down the explanation about the result, and then you move ahead and then start reducing the data. Because why we want you to do that, here you have all the attributes. If your attributes are 30, after processing, you did not remove anyone. You only what? Pre-process it. So you have your full attributes here. So you need to see the model with a full attribute, all the attributes. And then when you have the model with all the attributes, then you go and do the reduction after you develop the model. And then that will help you to know, okay, now at the end of the day, how can you compare the two? The one with the processed data and the one with the reduced data. Now we are going to do the reduction. Maybe you may need to reduce the data to maybe 10 attributes, 11, 12, 13, 14, maximum of 15. This is why we say relevant attributes. So then this is a task 3. This task should be done after you have run the model in part B using relevant attribute from previous step. So once you have this file processed, then you skip this portion, move to B, and start developing the model. I will explain this one later. And then come back to A4. So now for A4, it's a reduction. Then this task should be done after you what? You develop your model. Usually data mining data set are too large to process directly. Reduction can be done on the attribute, select attribute option. You have it in the weaker. And also the samples or sampling. Sometimes maybe we say 3,000, not less than 3,000 instances. Maybe the instances you have downloaded maybe 100,000. So maybe it's too much. Then you can apply a particular filter. That is a filter also for sampling. Then you can do the resampling and then select some portion of the data, maybe 3,035, then discard the rest. This is a resampling. All this is part of the reduction. So you can either use select attributes or you use the filter for sampling to take approve a proportion of the sample of the data. And then explain your reduction, reduce data set, what do you reduce, and then how did you do, what method do you use, and then what evaluator do you use, and then explain. Then compare the result based on the several features, preferably it's more than one different data, different set. This is why when we do the reduction, I think I asked you to use the ranking method, for example, so that we can have different sets. Now you use maybe greedy stepwise. You have the set, maybe for 12 attributes. Now you save them. Go back to your original data, for example. Okay, now apply best best. Now you have another set, 12 set. So now 12 data, the 12 attributes. Now you can have 2 or 3 sets data so that you can apply, you can use them to develop the model so that you can have a basis of comparing different methods of what? Selection. That is it. Okay, so now, as we said, now the last is to save the file as what? As reduced data. Now you have your what? File number 4, which is what? After reduction. Okay, this one also, you can screenshot some rows and then put in your document or your slides. So next is where you are going to develop the model. So by default, each group requires to develop a classification model. Apply an algorithm under the selected study using your data set. You are free to apply the algorithm, present the outcome of the project, and then each member has to elaborate his or her role in the assignment. This one will need for further explanation. And then if you are group interested in clustering, then we can discuss, you can do it. So these are the activities you are going to follow in doing the classification, in developing the model. You have already performed tasks A1 to A3 up to the process file. Then you select these test options as we did today. Develop the model using different test option 1, 2 test option under cross validation, K10, K20. Then the percentage split, 70-30, and then 80-20. What do you mean by percentage split? As I said earlier, 70 for training and then 30 for testing. The next one, 80 for training and 20 for testing the model. Then generate the tree visualizer of the best result from the cross validation and percentage split. Look at this and say which one gives you the best result in the tree. Then you can screenshot the tree and then put it in your slide and tell us this is a best visualizer, the tree. And then apply reduction method, that is A4. Then repeat the process, the same process as above, and then develop the model with the reduced data. And then finally compare the evaluation results. Maybe you tabulate them in the Excel. This is why you have the reduced data, processed data, then compare the accuracy of the result. Explain your result with the help of the graph charts. When you have it in your Excel, you can also plot some charts to show us how the data, how the classification result looks alike. Okay, and then this is the option for clustering. So maybe if you are interested in clustering, definitely you have to do all the pre-processing up to the process level, because you need to do it, whatever task we are going to do, we need to do the pre-processing. But this is what we are going to do if we are going to do the clustering. So maybe we can leave this one now. If you are interested in clustering, maybe after we discuss the clustering in class, you can easily understand it. Because now we talk about the investigating the errors using a gradient design, you may not understand it clearly. But when we discuss it in the class, maybe you can understand. So if you are interested, this one is optional. If any group is interested to do the clustering, then you can reach me out and discuss it with me. So this is the process flow. First is what? Is to get your data set. That is data acquisition part. Do the data preparation and pre-processing. Now you have the relevant features with the processed file. You develop the model using this flow. Develop the model using any algorithm, 1 or 2 algorithms. If you want to apply 3, yes, you apply 3 algorithms, depending on you. The more you introduce more algorithms, the more you can get more marks. So then model evaluation, do the evaluation and report the results in Excel and plot some graphs, and then describe the tree, and then show us the knowledge that is discovered, that is the roots, the knowledge that is discovered there. And then you do the reduction, and then also use the reduced file to do the same. That is, develop the model, show the visualization tree with the reduced data, and then tell us the knowledge that you discovered. These are the 2 things that you are going to, 2 data sets that you are going to use for creating your model. So how about the group? This is a group project where we are expecting you to have 5 members in the group. From the project, return your outcome, and submit the slides and the data set, and then even the models. You have to be saving the models. Because in your folder, we need to see your presentation slides, the data sets, different data sets, the original data, clean data, processed data, reduced data. We need to see all this in your folder. And then also the model you saved. And then the most critical thing we are going to do now is actually finding the best data and defining your problem. So take your time from this week, starting this week to next week, and then make sure that you get the right data you are going to. And then this data approval is based on test campus stuff. So I'm going to upload the templates in the Teams class, the class that I asked you to join. So I will share the link with you so that you can upload your data set and following all the necessary information. Then it satisfies the conditions, and we just give you approval. Then, okay, so some useful links to get the data set, and we have already given you this one initially, seen right from our first meeting. You can go to the Kaggle, use the CI and other relevant repositories. So what is expected from you? The presentation may be a live presentation or recorded, or even though actually we are not going to do a recorded presentation, it's going to be live, either physical or online, but it should be live. Every presenting member has to put his camera on. For what? The presentation is going to be for 30 minutes, and the Q&A is going to cover 10 to 15 minutes. Then to make sure you prepare well for the presentation, every member should know where to present, then this contribution. So these are the submission files, presentation slides with the pictures and the information about the student in the first slide, and then the completed data set, the original data in CSV form, and then the data set, clean data, process data, and then the reduced data. So these are the data set we need to see. This normalized one, I think no need to normalize, it's just about the process data. And then the model you develop for the experiment. And then if any the article, maybe you find out the article that uses your data set to look for that paper, then you also upload it in the folder. And then we are going to give you once you are in the class, then you can upload in your group. I will create the group folders, so that you can upload into your group. Okay. And then naming the data set, make sure you use the initial data set you download, rename it to be okay, which is your group, CSC, CDCS maybe 2305A, and then what is the name of your data set? Maybe diabetes data, soccer data, and then what is the name of the group leader? So now you can write the name of the group leader at the end. So now you save the data set like this. So this is the project timeline. The time is going. You can go through it and see activities starting from even though actually you're supposed to finish data understanding by week 7. This is week 5. In the next 2 weeks, you're supposed to finish compiling everything about your data and the data understanding part up to week 8. And then by week 8, there is overlap with the data preparation. And then up to week 10. So starting week 10, we expect you to start developing your models. And then as you are developing models, concurrently, you are also evaluating the results, that is analyzing the results. So now it depends on you. You know how to divide the tasks among yourselves. And then by week 13 and 14, we are expecting to have a presentation where we are going to deliver the outputs of So the rubric is here. So you can go through it. I think we don't have time to go through the rubric, but you can read and then follow how you can get a very nice mark. Make sure you refer to the rubric whenever you are doing the project, because rubric will help you know where to get the better marks, how to get the better marks. So try and follow the rubric. So this is the information file, group information, which I will share. I will share the Excel format in the Teams, and then I will share the links with you with all the groups so that you can put your information about the data set, information about the group members, the title of the project, the data set link, and then the remaining information. Because information in the template is beyond these ones. So that is all about the project. If you have any question, please go ahead and ask your question. Do you have any question?
So far, no, sir.
Okay, so Alhamdulillah. So if there is anything, maybe because I need to be checking the progress. So maybe you have any question, you can reserve it and ask it when we meet next. So you can go back to your work now. I will give you some time, maybe up to the midnight, to prepare your file and submit. So I will share the submission link, and then the form will be open up to midnight today. That is 12 a.m. Right?
Okay, sir.
Okay. So
Before 12, right?
Huh?
Before 12, is it?
What?
The submission is before 12
Yeah,
midnight, right?
before 12 midnight.
Okay. All right. Thank you, sir.
Thank you. Jumpa lagi. See you
Jumpa next
tomorrow,
week, sir.
Rizal. See
Thank you,
tomorrow.
sir.
Thank you. Till we meet tomorrow,
Thank you, sir.
Rizal.
Thank you, sir.
Thank you, sir.
Thank you, sir.